Thank you for the introduction. Okay, perfect. This is looking good. Hey everyone, this is Alex, and in today's session we'll talk about bug bounty program and LLMs. So basically, how are we using LLMs to improve the bug bounty program? Cool. So we will start with an actual vulnerability report. So this qualifies as the HackerOne report for sure. This is, I guess, an information disclosure report. So it seems those hackers found some details about me. So I'm part of Adobe's product security and incident response team. My tasks are usually around the bug bounty program. So I'm responsible for vulnerability triage, CVE metadata, publishing it, for all kind of stuff like doing automation, live hacking events. And actually, we do have a live hacking event right now at DefCamp. And apparently, there's some other information, something about me doing cha-cha-cha around vulnerabilities. Okay, that's something new that qualifies as PI. So I'll pay the bounty for the researcher. Cool. So diving into the subject. The subject for today is how we want to actually, and why do we want to expand the bug bounty program? Well, expanding the bug bounty program usually comes with a lot of benefits. So one of the benefits, like the main reason, is you'll find more findings, so you'll actually fix them, and of course, you're making the product more secure. You're fixing more vulnerabilities. But once you receive more findings, you actually kind of get some kind of a pattern. So you see your product, and you'll see a lot of findings, right? So when you see all the influx of the findings, maybe you'll establish, okay, this is a common pattern. Maybe I can address the root cause and just not whack-a-mole fixing everything. So your approach here is some kind of a strategic remediation. So what I tell by that is to work with other teams. So it's beneficial, even if you're in the bug bounty space and you work with the product teams, it's better to involve other teams. And many teams, maybe in the shift left area, can have a word on this. And for example, you discover by bug bounty program that your product is not good on XSS. A lot of findings against DOM XSS, stored XSS, and all of that. So what you can do, you can actually use this data, and you can go to actually the product security engineers that configure the SaaS. So you can maybe create custom SaaS rules, like a custom SEMgrep rule to detect all of these misses, so you are shipping, less vulnerable code to production. Also, one team that can actually be influenced by this decision is the threat modeling team. So whenever you're in the design phase, you can actually go and talk with the developers and okay, these are the features, but how are you doing input validation? How are you doing output escaping? So you can have this conversation. You can talk about counter-security policy, but yeah, the bug bounty program, this data can influence the shift left testing strategies. Of course, there are some considerations. Well, you expanding the bug bounty program and actually can lead to more increased budget. So of course, you'll have more findings, you'll need to pay them, more dineros, right? So basically, money is a problem and a consideration, and of course, the increased bandwidth, because both for the security teams and the product teams. So for the security teams, you'll have to do more triaging, validation, reproducibility. So of course, you have to do this ping pong with the findings, again, with the product team. So bandwidth is a concern. And also, for the product teams, they'll need to add more releases to fix those findings. So there's a lot of human work involved there. So how we can actually achieve the benefits. So there are two main reasons. To expand the bug bounty program, you're looking for to increase the scope and the hacker engagement. So for the scope, it's just product onboarding, right? So with product onboarding, you basically will have a conversation with the product team. You discuss all the details. These are the requirements from your end, and you'll ask them, okay, what's your preferred communication method? How do we get these vulnerabilities assigned to your product? You'll have discussions about the policy testing, like how the testing should be performed. Maybe discuss about sandbox environments, all the details that are very specific to each product team. Also, will be beneficial while increasing the scope to have a both public and a private program. So not all products maybe are suited to be in a public program. Maybe you can start with them in the private program and leave the others that are, have a more mature security program on the public one. Or maybe you don't want to onboard on the public program the products that require licensing or test accounts. So have that into the consideration. Regarding the hacker engagement, well, hacker engagement can be achieved in many ways. So one example is bug bounty campaigns. So bounty campaigns usually represents you list, for 1 month a product, and you'll say, we give 2x bounties this month for this report. So the actual benefit is that you can spotlight the attention for a product in this month. And the hackers, of course, they'll want to actually go and pen test the product because they'll receive more bounties, right? And you can do that for new products, testing out new features, or maybe the product is not receiving that many findings, so maybe you believe it's secure, so you'd want to go to the next level, right? Another cool opportunity is the live hacking event. Like I've just said, we have one there, so you work with the hackers, so you have both the security team, the product team working together. It's really nice. It's a really nice activity. And another one is the Hall of Fame, because usually researchers are interested in the reputational aspect as well. So you can be creative around it. So for a Hall of Fame, for example, you can do top 10 researchers of the quarter, right? So, and you can establish that by, for each report, you maybe assign some points for each severity. So medium findings can receive 2 points. Critical findings can receive 10 points. So this can be done with automation. At the end of each quarter, you'll calculate the points and post, make a social media post, or just use your website to actually post the results, and maybe you can give swag to the researchers. Right. So about the considerations, I mentioned some considerations. The first one was budget, right? So you need leadership buy-in. That's the point. So the recommendation for this one is to actually have a metrics-driven approach, a measurable one. So depending on what you actually have, you can consider to start with a vulnerability disclosure program. So basically, for this one, you're not paying anything. So you receive the reports. You, again, will involve the reputational aspect. So the researchers are gaining something. And you can use, for the metrics, the bug bounty platform stats, depending on what you want to use. HackerOne has some cool dashboards. Also, it would be beneficial to actually take the reports and actually move them to some ticket management instance that you have, like, I don't know, Jira, ServiceNow, and ticket the findings there. You can get the status of each finding, and do some intelligent analysis on them. And you can go extra mile with this, so you can actually visualize the data using BI tools. So that will mean you'll have to get, for your ticket management system, you'll get, for example, with a data engineering platform like that, yeah, Databricks can be used. Databricks can be used. You'll take the data with Databricks, and then you connect with Databricks automatically into Power BI. You'll deal with the data. You'll create some tables, and you import them in Power BI. And all of this can be automatically done. So you'll have the data real time. You'll have some cool dashboards. So leadership will be interested to find in this dashboard something like for each product, what's the criticality of the product itself. Like how many findings does it have? Are there medium findings? Are there critical findings? How many bounties did we spend on the product? Information like that. So around the concerns, also there was the human bandwidth consumption. So to deal with that, of course, automation will solve a lot of problems. So to use that is actually beneficial to So for example, for bug bounty reports, what you can do, you can do automatically from a report, create a ticket in something like Jira or ServiceNow. And you can use automation to dispatch a finding to the product team. And via email or whatever APIs you have it use. And that can be done with multiple tools depending on what you have. So that can be a SOAR platform. And the subject for today is to actually involve LLMs into this. So yeah, basically the presentation starts here. So what I'll want to do is to present 4 use cases, very generic, about LLMs in the bug bounty program. It'll be very generic, so depending on what tools you have at hand and actually what problems are you trying to solve and what products do you have, it can be from general to very specific. Cool. So the first application I'm going to talk about is the CV descriptions. And that usually benefits the security team. So what's the whole idea behind all of this? So the idea is that some bug bounty findings do require a CVE. So uh, usually when you ship a CV, you need to ship a CVE to MITRE. And those CVs are actually audited by NVD. So when you ship those CVs, usually there is a JSON file as part of the metadata process, and usually that JSON file contains a description. So usually when you're publishing an advisory, you can have many CVs. You can have 5 CVs, you can have 20 CVs, but you can have, I don't know, 100 CVs. So you don't want to do that task manually, so completing, 100 descriptions for your CVs. So you can actually use an LLM to generate the description for you. So the whole idea behind this is to leverage an LLM API. So the technique here will be a few-shot prompt. So you're giving the LLM some examples. Okay, this is the vulnerability. This is the impact. So I usually categorize my examples on the CWE, which is common weakness enumeration, and the impact information. And using those, you will generate a description. And you'll give those examples. This is the few-shot prompting approach. And I want to give the exact, let's say, descriptions that I want to publish. So I actually use some real data that I want to be published on NVD databases. So we ensure that those descriptions actually will pass the audit. So the first step in this is when constructing a prompt on this, you can attribute a role to the LLM. So you'll basically say to the LLM, OK, so you're an application security engineer. This is your task. You have the CVs. You have to create a vulnerability description for them. And I usually say to the LLM something like, take a deep breath and work on this problem step by step. So usually machine learning engineers have found out that this phrase will provide the LLM, it will just generate better results. So I usually include this just to make sure the quality is good enough. Also, while moving from the role to the instruction section, I usually in the instruction just tell what I want to do. So in my example, I will tell the LLM, so this is the CWE information, this is the impact information. I want you to generate a vulnerability description. And the thing is, when the vulnerability is present in the examples, I just want the LLM to take it from there and not reinvent the wheel. Because at the end of the day, when you're publishing a security bulletin, you're kind of expecting some of the CWE. So for example, XSS is common, buffer overflow is common. You can already have in the examples those vulnerabilities, right? So you'll have the examples there, and the LLM just don't have to reinvent or craft something new. It's just taken from there. So that usually works. But for instruction number 2, for those cases where you don't have an example, or maybe the example is too tailored, it's too specific, you're telling the LLM to craft a new one based on the examples. And usually he's trying to do that, and it's kind of a similar description to what you provided. OK, cool. So regarding the examples, I just gave an example. So for example, for CWE, out-of-bounds read and impact memory leak, this is the answer. The reason that after the answer, it's saying directly, are affected by an out-of-bounds read vulnerability, usually I'm not letting the LLM to generate the product information. I just want to take the product information directly from the automation and again, the affected versions. So basically, the answer in the end, when I'll take this answer using automation and append it, to my whole workflow of shipping metadata, will be something like product X version A, and yeah, then will be just the LLM output. OK, cool. So moving out to the next application, it's called the vulnerability auto-enrichment. So what's the whole idea behind all of this? So when you have bug bounty findings, right, so you'll need to calculate some things, like CVSS score, for example, CVSS string, you'll need to determine the vulnerability itself, so the CW information. You want to know the affected product, maybe the impact, and all of this will be basically manual information that will be typed in. So I would like to predict all of that. So when I'm seeing, a vulnerability, I will already have this information there. So what's the whole idea behind it is to leverage what you already have. So that's what I said. Assuming you have a ticket management system, you ticket the reports from HackerOne, for example, to your ticket management system. I assume you already have these vulnerabilities, and you can use this data to actually predict the new ones. Or maybe there are similar ones, and you just want to reuse, again, the CVSS score. So for example, I assume you already have maybe received a vulnerability around server-side request forgery. So you'll take basically the same, or depending on how the report looks like, you'll be very close to something that you already received. So the whole idea, so this is basically a RAG capability. So you're using the ticket management API to actually build a connector with your LLM. So for example, with Jira, you can get a Jira connector. So each time you receive a finding, you can have a JQL connection to actually gather the vulnerabilities. So you can use them as knowledge base. So one workflow example, so I usually performed this, and I thought it was a good idea in my head, is to have two separate calls. So I firstly want to determine the product information. That's not a hard thing for an LLM to do. So the first call will be kind of a zero-shot prompt. So you can use actually HackerOne High if you have HackerOne. So HackerOne High is just an LLM provided by HackerOne. So you'll just tell the LLM just a simple prompt just to identify the product information. You give them the list of the products, and you'll try to give some tips like mapping the URLs and sandbox environments to the product itself. So while having the product, what I'll want to do with the Jira connector that is integrated into the LLM is to create this JQL, and we'll actually filter by product. So you're basically getting all the vulnerabilities that product received, and you'll take them into the knowledge base. The knowledge base will be into the final prompt. So actually, to query this in for the LLM, you can use the vulnerability summary. So the vulnerability summary of the received finding can be used. So you'll take that, and you can search through the descriptions of the received ones by the JQL connector. OK, another application. So this will benefit mostly the product team. So it's called fixed recommendation. So this, again, is kind of a few-shot prompt approach. You'll give to the LLM descriptions. You can do like real reports with a description, and then you'll provide them with fixes, like good fixes that you would like these fixes to be provided to the product team. You might want to ensure that those fixes are great. You'll just talk with the product teams. Does this fix look good? So that's usually what you can do. And of course, it can have a RAG model capability. So basically, you can actually have for each product, you can define what's the product technology stack. So this product, does it use Java? Does it use .NET? So it will be good to provide tailored descriptions. And also, you can tell in the RAG capability, like the approved security libraries, and also some known standard fixes. So for example, for a product that has a lot of subdomain takeovers, there's pretty standard vulnerability, and it has a pretty standard fix. So you can already give the fix directly to the developer without the LLM reinventing the wheel. So for subdomain takeovers, maybe your product uses AWS, and you'll just tell, OK, so go to Route 63. You have to find the CNAME record and all of that stuff. And the fixed recommendation schema can be like this. So firstly, you'd like to say to the developers, like, OK, this is the reason for the vulnerable code or configuration. And then you'll try, so the LLM will try to provide an actual vulnerable code or configuration. Maybe it doesn't have that in the report, but it can interpret the vulnerability and actually generate a snippet of code. They already have the language that the finding has. So basically, it will provide some kind of code. So because in the next section, you would like to provide the fixed code. So taking the old vulnerable code and add some lines of code to fix it. So the developers will kind of have an understanding of what needs to be done. And in the final section of the schema, you can provide something like why the suggested fix should work. So it's basically the developers will have a full understanding of all of this. And last but not least, this similarity search application. So usually this is benefiting both the security team and the product team. So similarity search will help us to identify duplicates, spot duplicates. So whenever you receive a report, you'll see, OK, so these are the similar ones. Maybe some of them are actually a duplicate. You never know. So it's good to have them grouped. And also, maybe it can address same root causes. So you'll see that there is a finding, and it has a lot of other similarities. Maybe it will be, you can identify root cause, same patterns. So it would be good. Also, product teams can maybe reference some old fixes, because maybe when you receive an old findings, maybe you determine that this is a regression of something else, and you better check out that fix. So again, another application of this is you just to identify the reporting trends. So again, you'll see that your product, when you receive, for example, an improper authorization, and the similarity search algorithm will identify 10 more that you fixed, it seems you have a problem there. So usually the similarity search is good for that. Also, as part of the implementation, so again, you'll have the database, the ticket management solution with all the vulnerabilities. You'll take the vulnerabilities descriptions right there, and you convert them into vector embeddings with an LLM. So once you have that, you'll store all of the embeddings into the vector database. And while you have that, that's already there. When you receive a new finding, you again will take the description of a new finding, and you convert it with the same algorithm into a vector embeddings, and you'll compare it to the vector database, the existing one, using the k-nearest neighbors algorithm, and that should give you an output of the similar ones. Cool. So, great applications solve some problems, but not everything can be solved with AI. So, imagine LLMs responding to bug bounty hunters. Well, I think that will generate a lot of frustration. So, we don't want to do that, and actually can be very harmful. It can lead to prompt injection. So, definitely not going to solve that problem. So, again, also relying on the LLMs to determine bounty decisions. So bounties is a delicate subject. So in the end, the human touch will be the one making the decision. So you never know when LLM overpays a bounty or underpays a bounty, and again, will cause frustration. So yeah, basically, that's it. So happy to answer some questions if we have time. If not, you can find me at Adobe booth or at a Hacking Village, and you can always Slack me, or find me on LinkedIn, right? So yeah, happy for questions.
Thank you so much. Let's give him a round of applause, please. And we have 2 questions already here. 3 questions.
Hello, Alex.
Hello.
Thank you for your presentation. What kind of LLM did you use? Have you tried multiples?
Sorry, what kind of what?
LLMs.
Usually we use Azure OpenAI, but I guess most of them are good. I mean, you can do something, more custom depending on your needs, but there are other models out there.
Okay, and my next question, did you use a local one or cloud-based?
Yes, we did use something internally. Yes, we have a specialized machine learning team, so yeah.
Okay, thank you.
He will be back in the front too, don't worry.
Hi, thank you for your presentation. Do you
you.
think that in the future there will be less cybersecurity jobs due to AI becoming more advanced and powerful? Like,
Can
would
you
there be
repeat the first sentence? Like, I could barely hear it, so.
So, do you think that in the future there will be less cybersecurity jobs because of AI becoming more advanced? And
Oh, definitely no. I guess with the rise of AI, actually will lead to other problems. So, there are already a lot of discussions on, OWASP LLM top 10. So, and you'll have, some engineers working on this to implement this AI workflows. So, it'll definitely solve some problems. It'll help you to scale more, but there will be, you'll need more specialists to deal with it as well. So, I don't see this affecting the market.
Okay, thank you.
But that's just my opinion. So.
Hi.
Hello.
Very insightful presentation, by the way. I have a question regarding the description you mentioned. You said that the CV submissions get audited by NVD. Now, how often those descriptions pass audit?
Well, it's a great question because it kind of relates to what you just said. So usually, when I generate a description, NVD actually audits it. But I mean, there is always the need for human touch. So the LLM doesn't provide full accuracy. So whenever I ship this to MITRE, I already know what the NVD analysts actually expect. So I usually modify from time to time for some vulnerabilities, some just tweak the description for things the LLM can't know for sure. So for example, in the CVSS score, the CVSS vector string, you'll have the user requirement if it requires user interaction. So if it requires user interaction, the LLM it's quite unsure of that. So I usually try to tweak it, so add it into the final description. So yeah. But usually it's good.
So in the end, you still need to tweak.
For some of them, I usually know what to tweak. There are some specific isolated cases but for 95% of the findings, I don't even touch it. So yeah.
Thank you.
You're welcome.
I think we had one more question.
Thanks for the great presentation.
Thank you.
I had a question about privacy concerns on this.
What?
The privacy concerns.
Oh,
of, yeah, because let's say either on the bug bounty hunters side or on the organization side, how do you know if your reports or what do you do regarding your reports so that other organizations, let's say OpenAI or something like that, they don't train your data, they don't train their AIs on your data, sorry. If you want, I can repeat it.
So you're telling me about the, can you get,
Like, big AI companies train their data, train their AI models on your data and prompts, I guess?
yeah, so I'm not using HackerOne data to influence quite my model. So maybe I'm just not hearing it enough. Sorry, I just barely hear anything. So
Yeah, like I was talking in general. Okay, that works better. So I was talking in general, either on the me as a security researcher submitting a bug report to you and using AI models to do my research, or on your side, on the organization side, using AI models for this. My question regarding this was, how do you ensure that they don't, the AI models don't use the training data that the prompt that...
The tracking
Sorry?
The what capability?
Training
capability?
Like they don't train your data, they don't train their AI models on your data. How do you ensure that? Like privacy concerns? Sorry,
Yeah, well, maybe for that, we can actually talk offline and debate.
Yeah.
Yeah, meet me up there.
Yeah,
then,
sorry, yeah. All right.
Yeah, I'll have to debate on that.
I think we have time for one more question here in the front, and then we'll go for lunch.
So you discussed part with Nikolai as well about the LLMs and the CVSS scores, but how good is the prediction? Like you said, you have some tweaks, but if you do have some tweaks to do, how much time do you work on them? Like, what's the time adjustment help now that you're using this?
Well, I don't spend too much time on the tweak, so yeah. The question was around the.
How good is the prediction now with LLMs? regarding the CVSS.
Oh, the CVSS score, yeah. So usually for the CVSS score, usually not letting the LLM predict the CVSS score. I'm taking the CVSS vector string and then I use a Python function to create the CVSS score out of it. But usually pretty good. I guess it depends on how polluted is the data set. So if the data set, for example, in Jira, it's not quite good, yeah, the predictions won't be that good. It depends. So, but usually there is a team, of course, analyzing it every time. But it's usually good to have something there instead of nothing. So, yeah.